Hello, everyone. Thanks for joining us again today. My name is Charles Rice. I'm your host. Today, we're going to be talking about structures, specifically what's new in structures testing in Test Lab 2406. Your presenter today is Steph. Steph, you want to say hello?
Sure, yeah. So hi, I'm Steph Nelson. I'm an application engineer for Siemens, and this what's new is going to be very new because Neo used to have impact testing. It sort of had like a version of it, and it got a whole, I should say, makeover. There's a ton of stuff that's new, some really cool things you can do that you couldn't do before. Specifically, there's these FRF merge tools that we can use now that are awesome. And you can also use virtual instrumentation. So I'm going to walk you through some of that, and I'm also going to show you really quickly. I don't have time to talk about it today, but we did also, because it's part of structures, we did update our modal correlation. So if you are completely new to modal correlation, what we introduced in 2206 and 2306 was the ability to take FEA modes that you have calculated and match them to test modes in a MAC correlation matrix. And you could align them and do some cool things. But what we wanted to do to make things easier to use is we've added this alignment feature. So before you could just kind of align them and turn them around and hope they were aligned, but now they line up over each other so you can see if the fit that you got is actually going to be useful. We have a new dedicated alignment task to make sure that what you actually are selecting is where they're supposed to be. So if you've used the modal correlation, this tool is going to be a little bit easier to use if you're comparing to like CAD models and stuff that you've solved for.
Sounds exciting.
So the big thing is this impact acquisition. It's called impact acquisition, not impact testing. So if you're used to the old software, well, I guess everything before this would have been called impact testing in Test Lab Classic. We have a couple new things that we have added. So the first is, and sounds weird, but actually is really cool. Only the time blocks are stored during the measurement. What this allows us to do is we are able to change measurement parameters on the fly and automatically recalculate all those FRFs. So every time I take a hit, and you'll see me do this today, I've got a little setup here. Every time I take a hit, it's only storing the time data until I'm completely done with my measurement and I tell Test Lab I am all done, then it'll calculate the FRFs. But it makes measurements much quicker, and then if you're doing a massive large modal test where you have 5 or 10 hits per location and like 100 locations, it really helps save on data and space. It makes Test Lab run much faster. All settings on the time blocks can be changed at any time, and I will show you what this means. This is really cool. So this means like if you find out after the test that your trigger level wasn't set properly, you would, in the old software, have to redo all those hits, or you'd have to try to reprocess them outside of impact acquisition, which can be difficult. But now you don't have to do that anymore. If you go back to the setup tab and you change your trigger window, it'll update all of those time blocks, recalculate them to show you what your new FRFs look like. And then FRFs are stored at the end when you're ready to save everything. Another cool new thing, this is really, really big, is we have a multi-hammer and auto merging in impact acquisition. So what I mean by that is you'll see today I have 2 hammers. And I'm going to go over this a little bit in detail in case some people are new. I've got one with a rubber tip, and I've got one with a metal tip, and I will be impacting with both of these. If you're not new, then you probably have some idea of why you would want to use a metal one sometimes over a rubber one. But with this new version of the software, you actually don't have to choose. You can use both hammers, and you can use this thing called an FRF merge, this filter, and what it'll do is it'll be the best of both worlds. So if you're interested in low frequencies, you can impact with this hammer, and if you're interested with high frequencies, you can impact with this hammer, and then it'll take the combined FRF and it will merge the two together. And then I'm also going to show you what that data looks like if you were to only use one over the other. So it's a big advantage if you're trying to do quick automated testing. Obviously, there's different types of tips. The rubber tip's a little bit better at exciting those lower frequencies, and the metal tip extends out much higher on the higher frequency. So one of the things we can do in the software, and this is a video that I might show later, is we can combine those hammers together. So I'm going to open Test Lab. And when I open Test Lab, it's called Impact Acquisition. In fact, I will show you what that looks like if you are brand new. So I've got my Test Lab 2406 icon. If I click on that and go to Neo Structures Acquisition, it's called Impact Acquisition, not impact testing. I know it sounds very similar. but it should open and it should look like this. There's a couple other things I forgot to mention on the slides. This also works with virtual instrumentation, which is very cool. I will show you what that looks like with my little metal microphone stand I have here. Because I have 2 hammers, I'm going to turn on 3 channels. I have a single axis accelerometer here, and then I have my 2 hammers here. And this is different from the original test lab in that I can now select multiple references because I can have multiple hammers. So I have 2 references here. I'm going to turn my conditioning very quickly to ICP. Now, normally, if you were in Classic, you would set the direction and the point here. We are asking you not to do that because there's a dedicated portion for the hammer to do this. So if you do this, it could end up getting screwed up. So don't set your hammer stuff here. And then there's a special spot to set your accelerometer location. I'm going to set these to force. This should all look very familiar if you're used to our other software. And I'm just going to type in the sensitivity values really quick. I could read the TEDs, but I want to go a little quicker. Okay, so here's my setup. Now, if I want to do a geometry, I'm going to show you the cool way to do it first with virtual instrumentation because I think it's really nice. I can go into geometry, and now if you've seen virtual instrumentation, you've probably seen it implemented in virtual point transformation or something like that. You don't need to open virtual point transformation or anything to do this. All you need to do is to go to Files, Add-ins, and I have virtual instrumentation turned on. And when you turn this on, if I go to my geometry tab, it'll have this virtual instrumentation here. So I can load in CAD models if I have a CAD license. And here I've got a JT. This is a Siemens proprietary file structure, so I don't have to convert it. If you did need to convert it, there's like a conversion license. So like if I wanted to add a SolidWorks file, for example, then I would have to get a conversion license. But because mine's already in the correct file, I don't need to do that. I'm going to click OK. And what you should see is this microphone stand in front of you. My CAD model actually has the microphone in it, but I have elected to not take my microphone out of my hanging stand and put it in here. So we're going to have to use our imagination. Hopefully, everyone can imagine that this has the microphone sat inside of it. So here's my microphone. And one of the really cool things I can do about this, oh, actually, I'm going to turn these buttons on too. So I have these buttons turned on. When they're red, it means I'm left clicking. When they're blue, they mean I'm right clicking. So hopefully that helps. So I have this model here. And what I'm going to do is I'm going to find the accelerometer that I have set up, which is a single axis accelerometer. And I'm going to put it here where it's set up on my stand. And this is cool because it'll automatically put this normal to the plane that you click. So you don't have to worry about making sure that it's really close and lined up, having 2 faces meet as if you were doing it in a proper CAD software. And this is also going to be much easier to define what we call a campaign later. So in this step, I would put in where all of my excitation forces are going to be. So maybe I want to impact here, maybe I want to impact here, and maybe I want to impact here. And if I didn't like any of those locations for some reason, I could click on one of them and I could scoot it forwards and backwards. But I think this is pretty good, so I'm going to leave it the way it is. Now that I have virtual instrumentation, I'm going to go back to instrumentation really quick. Go to geometry lookup. This is like that tab in Test Lab. It used to be like up here you would click geometry and then you would be able to see it. Right now it just looks like a bunch of nodes because these are my impact locations and my references. If I click on CAD display, then I can see my references in my accelerometer. So I'm going to assign my accelerometer to this channel here. So if I click it, it'll pop up and say this is node 1. I want to highlight this row and click assign to channel. So it's very similar to the other software. It's just in its own special dedicated tab this time. So hopefully it's a little easier to find. It's not mixed in with the TEDS tab or anything. Once I'm done, I can go to impact. And another pro tip, you might see these are a little more cleaned up. I don't use some of the other tabs up here. If you're new to Neo, there's a quick way you can do that. This is not unique to impact testing, but if you're using Neo for the first time, we have these tasks and you can actually come in and you can hide tasks. So before in Test Lab Classic, they were workbooks and you could go into the workbook and you can hide them. But here's the way that you can hide them here. So I've got all of mine hidden. So I just don't want to confuse anybody. If they open it and they see they have like 30 more tabs, I don't use a lot of them, so I have them turned off. Here's my hammer setup. So I'm going to add 2 hammers. I have in channel 1 my rubber tip. So I'm going to rename this as rubber. And channel 2, I have my metal tip. Now, if I didn't have a reference channel turned on, this would look just blank. It would not have these here. So if you ever see a blank level, it just means that back in the instrumentation setup, you forgot to turn on a reference. So channel 1 is my force. Here, channel 1 is my force. And I'm going to wait to apply this filter, this FRF merge filter, because I want to see what my impacts look like. So I can hit start, and I'm just going to do a couple of impacts. So you can see that the actual size of the impact is going to be much different for the hammer versus the rubber tip. I can eyeball my trigger level. So it looks like my trigger of 3 newtons is probably enough for both. I can change the trigger level for the individual channel. So this looks pretty good. Now for the spectrum, my FRFs here, if I click on this button, I'll click stop real quick, I should have the reference spectrum. And I'm going to zoom. Actually, one thing I'm going to do really quick because I don't need up to 3200 hertz. I'll do like maybe 1000. I don't really care much about 3200. I'm going to do some extra hits real quick. Some of those are bad hits. Okay. If I go into my FRF merge here, what I can do is I can basically set up these high pass and low pass filters. And this might be hard to see, but I saw on the last hit, it doesn't show super well right now. On the last hit I had, the frequency that the rubber hammer was really good at was up to about 300 hertz. And then after that, it sort of died down. So for the rubber hammer, I'm going to put a low pass filter on this with a center frequency at about 300 hertz. For the metal hammer, I'm going to put a high pass filter on it, and I'm going to put the center frequency at the same location. You don't have to put them at the same location, and you can change this transition width. This is good enough for me. The only thing that you cannot do is if I were to have my frequency here at 500, you'll see that I have this gap here, Charles. Do you see this?
Yeah, that's not good.
No, it's not good because it's 0. So what would be happening, it would be multiplying all of our data here by 0 when it gets filtered, right? That's not good. And you'll also get an error that'll pop up that'll say you can't do this because TestLab realizes that this is bad for your data. What you want to do is make sure that if you set these filters that they're set the way you want. I like to keep them consistent because half and half, these will add. So anyways, you can mess around with them too, and you can see how the FRF changes in real time. Like I said, we'll do some hits and we'll come back and we'll change some settings and we'll look at what that does to the data. Okay, here I've got my resolution. It's set to a weird resolution. I don't like that. I'm gonna set it to 1. My pre-trigger, I can set. Pre-trigger is a little different. This is not a guided setup. This is assuming that you understand a little bit more about impact than, let's say, our TestLab Classic software did. That one really kind of held your hand. This one goes a little bit quicker. If you have more things you want to enter about the hammer, you can save these. So I can hit save, and I could store all of these parameters. If I'm using the same hammer day in and day out, I don't want to keep entering in this information. I can save it in my library. So if I had a hammer library, I can pull it out from there. Another thing you can do is you can type in the target force level. So maybe I think for my rubber hammer, it's 10 newtons, and for my metal hammer, maybe it's 30. I can type in the type of tip, and then if I'm using any extra extender masses for bookkeeping purposes, I can keep that in there too. Processing advanced is where you can choose how everything is scaled. And like I said, these are variable. If you don't like these settings, you don't have to. This is designed to just quickly take data and then come back and mess with the settings if you have to make it what you need to be, especially if you're doing really large tests. Like I said, the really cool portion of this software is that if you have 800 node tests or something like that and you screw up, it's totally okay. You do not have to worry. You can keep saving data and keep reprocessing data on the fly. I have a force exponential window with a force cutoff at 10%. So now I go into campaign setup. This is also very different than Classic. In Classic, you could just type in your settings and hit go. In Neo Acquisition, you now need to define where you're going to be impacting. Now, if you did all of your excitation forces in virtual instrumentation, which we did, I can just click this button here and I can bring all my forces in. And the only reason you can't see it is because I have not made it a cat. So I can see all of my impact locations, and it'll also tell me in virtual instrumentation where I need to be impacting. So that's a really nice thing. If you want to do this manually, I will be showing you how to do this on the plexiglass plate back here. This is just with the virtual instrumentation. You can click this button, and then with regular impact testing, you can manually add degrees of freedom. If you don't like the way that this is incremented, maybe I want to start on this side, I can move this all the way up. So now when I increment my test, I can change how this is done. That's a little bit different than classic. Before, how you named the nodes was how it was. So if your node naming convention was not good, then you were forced to impact in that schedule. So this is kind of nice too. Okay, I can change my base name run. So instead of saying run 1, run 2, I can make this microphone test or whatever. Microphone 1. I can have it auto increment, which right now I'm going to leave it not doing that. This target impacts per hammer. This is really important because this has to do with the 2 hammers. So if you are using 2 hammers, the target impacts per hammer will ask TestLab how many expected impacts they have per hammer. So what I mean by that is if both of these, right now it's set to 5, if both of these do not see 5 impacts, it will not increment. So I could do like 30 impacts with the rubber hammer, but if I only do 3 with the metal hammer, because it's not 5, it won't go on to the next measurement unless you manually stop it. So you can set this to be what you want it to be. I'm going to set it to 3 because I've been having a really hard time with double impacts lately. Measurement advanced is where you can do the reject auto, overload, and double impact. I'm going to have both of those on. Obviously, those aren't good to have in measurements, so that's easy enough. But roving hammer, this is what we've designed this portion to do. Okay, there's no questions so far, right? Before I start trying to whack things?
Nope, swing away.
Okay, cool. So then obviously measure, this is where all the cool stuff happens. And I'm gonna open this tab. I've got this nice chart here. This will tell me how many impacts I've done with my rubber and my metal hammer. And then this will tell me, this is like a little table that tells me how good my measurements were. So in classic, you had to go out of the software if you wanted to reject a hit or you had to reject a bunch of hits. This one will let you turn off hits as you need to see how that'll change your FRF. And I'll show you what that means. I'm going to turn on that CAD software again so I can see where I'm impacting. So I want to impact, you know what, that's fine. I'll impact there. I'm going to turn this so I can get to it a little better because I'm on the side. And I'll click start. Oh, another thing that was added. I don't know if you heard that, Charles. Did you hear that on your end?
Yep, did.
The telephone? Yeah. So if you just loved the 90s sounds that TestLab Classic had, that is newly added to TestLab Impact Acquisition. If you're using the 2306 version, it's my understanding that those are not in there. But as of 2406, you can hear your favorite phones, your favorite window crashing sound, all of those. And if you wanted to change those to maybe be something goofy, like maybe it's your manager yelling, "Don't go overboard" for the overload signal, you could just navigate and reset them here. We have a colleague who likes to use the Homer Simpson "dope" every time you use an overload. So that can be changed out as well. But I will start impacting. Okay, I think I had it set to 3. So one thing you'll notice is here's where my data starts to cut out on this green trace, and the red shows the full spectrum and the green shows where it's hitting with that filter. Because remember, we have a low pass filter on this rubber hammer because we're merging the FRFs. Another thing that's cool is I don't have to tell TestLab which hammer I'm using. It automatically senses that. Ooh, that's what happens when you tap a hammer. This one I'm less confident about. Let's see how good I can do with the metal tip. So if I don't get a good hit, and I probably won't because this is a very metal structure, I got 1. There we go. Well, I'm not going to keep going because I don't want to be here all day trying to not get double hits. So I've measured one location and it shows I've done it with 3 rubber and 2 metal. Now, if I were to stop this and go to my desktop, all I would see is time data. I don't have any, I'll go into DOF ID versus function. I only have time data. I do not have any FRFs, and that's because I haven't saved any yet. If I go back to Impact, I can hit Save Campaign Results. This is the magic button here. And I wish it was a little bit bigger and more obvious, because this is where you tell Test Lab that you are done and you would like to save these FRFs. I'm going to hit Campaign Results Save, and I will just call these Merged FRFs. But if you're like, hey, that's cool, but I think the metal hammer was garbage, I don't like the hits I got with it, I can take hits out automatically, and it'll show me how my FRF has adjusted. You see how these FRFs are changing as I'm taking hits out? Maybe, and this has happened to me, maybe this has happened to you, Charles, maybe like you take a hit and technically it's not a double impact, but it definitely wasn't a good hit, right? Has that ever happened to you?
Oh yeah, you have your moments, everyone.
Yeah. So instead you can hit the X's, and if you have like 40 hits, you can actually see how that'll affect your measurement, and you can resave it with the hit taken out. Another thing that you can do, check force level of deviation. So if I have this set on, what this will do is it'll check how consistent my impacts are. And that's nice too, because if you have a bunch of different people impacting over a number of days, it might be nice to have something that checks whether or not your impacts are way out of the mean of what your normal impacts are. You can turn this on and off, and you can choose your thresholds. So that's another thing you can do to auto reject. I'll go back to measure. So if these are great, and for me they probably are, I can go back to hammer, and maybe I'm like, hey, I don't like that metal hammer, I want to turn that off. I can turn it off, go back to measure. Oh, actually I should turn off this filter. Go back here first, none. So now I'm using the full FRF. So this is as if I only took a test with the rubber hammer. I can go back to measure. My test has changed. You can see that here. And I can hit save. And I'm going to save this one as rubber only. I'll click OK. Now, just for fun, I can turn this one off and come here and put none. Go back to measure. This will adjust again, and then I'm going to say save. And actually, I'll turn this one back on just because I don't, otherwise it's one average, and that's not really great. Metal only. Okay, and I'll hit save. Oh, I already hit save. Okay, so if I go to the desktop, now I can see the difference between my coherence with my FRFs for the merged. Here is it with the metal, and here it is with the rubber. The coherence is on the top. You can see that the best one, I think personally, is the combination one. The rubber one has a lot of dropouts. It's really good at low frequencies, but as expected, it's not good at high frequencies. The merged FRF, I'll make it a little thicker. Curve styles. This is in a preview tab, so normally you're not supposed to do this way, but I want to go quick. So the red FRF is the combined, so it's a bit of the best of both worlds. It's got the metal high frequency portion and the rubber low frequency portion. And like maybe here, I think that the metal tip is actually a little bit better at like 240. I could just go back in and adjust those filters back in the hammer setup and then resave the results. I don't need to recalculate everything. That's the really nice portion. All I have to do is turn this back on, change the high pass and low pass filters, and then I can resave the results. Does that make sense so far, Charles?
Yeah, super flexible.
Yeah. Another cool thing you can do, and I will probably just show you on a video because I don't want to spend time loading, is after you've taken this virtual instrumentation point, if you want to animate it using ODS, for example, I could go to Files, Add-ins, and locate the operational data animation, turn that on, and I can come in and I can animate it. I've got a nice video that I made not too long ago in my PowerPoint. I think it's this one. So here, I'll skip ahead a little bit. This is me going back to the geometry tab. So I go back to the geometry, I load in an STL file version now, not the JT file, but an STL file of the exact same CAD model. I'm going to add all my data to the input basket. I'll skip through just a little bit. You can watch these all on your own. Now I'm in the ODS tab. In the ODS tab, I can drag the geometry in. So that's my original 4 points. But if I drag in that STL file and I click on a frequency and click play, you'll see that it starts to animate. I've only hit it in one location, so it's not really interesting, but it'll start to animate the STL file based on the singular node location. So that's the singular node location that I hit, but if I right click and go to animation settings, automatic geographical or automatic topographical, depending on what type of STL model you have, then I can get it all to animate. And if I skip ahead a little bit, here it's all animating together. And if I right click, I can enable the color and I can get it to, as I'm changing the frequency, it's going to change that mode shape. This isn't incredibly interesting to look at because we only did one location. If we were to do more modal locations, it would look cooler. That makes sense, Charles?
Mm-hmm.
Okay, I'm going to close out of this really quick and I'm going to open it up again. But before I do that, and I'm going to move this back because we're not doing this testing anymore. And I'm going to bring this plexiglass plate forward because this next portion is really going to be for you if you're not used to using virtual instrumentation. So I'm just going to put this accelerometer at an arbitrary location here. Everyone can see this plate. Is that right, Charles?
Even though it's clear, we can see it.
Yeah, I suppose. It's a thick plexiglass plate. If you've ever seen our impact demos, you've seen this before. Okay, I'm gonna breeze through this setup again. So this is now if you don't have virtual instrumentation, you want to take data the old-fashioned way using a wireframe. We're going to show you how to do that as well. A little bit more steps than virtual instrumentation, depending on how you look at it, but it's not bad at all. Especially because Neo makes geometry so much easier than TestLab did. Okay, I've got my setup. I'm going to go into geometry, and I'm going to create this plate in 2 seconds very quickly. So if you're new to TestLab Neo, we have a geometry creation. This is really cool because even if you prefer TestLab Classic, you can make all your geometry in Neo and then just open it in Classic. It goes way quicker. So I'm going to go add. This is a rectangle. I'm going to name this plate. And these are ballpark guesses because I don't have a measuring tape on me, but I will do a 2 by 3. I click OK, and bam, I've got my plate. No more needing to type in the individual node locations. How does that sound, Charles? Is that?
I won't miss it.
Yeah, I don't miss it either, I'll be honest. I just made this plate, 10 seconds, done. So now what I can do is I can go back to instrumentation, and in that geometry lookup tab, if I click that, I can pick a location, so here, and I can just assign it this way. So I have my plate 2 is here. One thing you'll probably notice is you can physically type in the location too. That's just like TestLab Classic if you're used to that. But I think it's kind of nice to get that confirmation that that location is where you want it to be. So I like to use the assign to channel button. If I go back into impact, I'm going to use just one hammer this time because I am lazy. And here's a perfect example. I did not turn on a reference channel. So this is blank because I was going a little quick. I'll go back and turn on a reference channel. In TestLab Classic, if you didn't have a reference on, it used to yell at you before you left this page. But we trust you a little more in TestLab Neo. Okay, so I will start. I can take my hits again. That looks good. My trigger level of 3 is definitely good. 3 newtons. I could probably go higher if I wanted to. I'll click stop. My resolution is 3 hertz, and I'll just make it 1 hertz just because. I will keep the measurement at 1,000. I'm not super interested in anything above 1,000 in this plexiglass plate. So this is the other thing that's different. So before, remember, we could just hit this virtual instrumentation button and they would all pop up. But now you kind of have to do it by hand. So if you click a point and you click this add degree of freedom excitation, oh, let me try this. It should have the name of the plate and then I can choose the direction I want to impact. And since it's a hammer, I'm probably almost always impacting in the -E direction. So I can click apply. But the nice thing here is that, once again, depending on how my nodes are named, this is node 6. So if I was doing in TestLab Classic, I would have to start here and then here and then here, unless I decide to increment and decrement a bunch. But when I'm making my campaign, I can make it in the order that I want to impact in. So maybe I want to make a zigzag. So I will add one here. I want to go here first. Otherwise, that'll be kind of silly. Okay, so now I have my excitations. And like I said, I can still move these around if I want to. I can click on them and I can see how this little hammer goes around. So this is very similar to Classic. The only difference, like I said, is you can't just measure. You have to define your campaign. So it's a little bit different. I will do 3 impacts again. Although it's a rubber hammer, so I'll probably have better luck. Go to measure. I'm going to bring up, I like to have this list up so I can see how many I've done. Excellent. Now, if I was good, I could increment to the next position and then TestLab would show me. I don't think I was hitting in the right positions. I've been arbitrarily hitting. Normally you want to match up with this diagram, otherwise your data will be kind of weird. But for the sake of the demo, I've been going a little bit quicker. So you could just increment and go across and collect your data. And even though this is only in the Z direction, because this is a plate, you should still get some pretty cool mode shapes because all the points will be moving up and down. So you'll get a lot of the bending modes and the rigid body modes. You should be able to see those. If you wanted, you could impact in 3 directions on like corners. Definitely cannot do that in the center. Although I guess because all of our nodes are on the edges in this plate, you might be able to get away with going in an extra direction or 2. And if there's any questions in general about what's new in structures, like some stuff that maybe you wanted to see that I didn't show, you can also email me at steph.nelson@siemens.com. I would be more than happy to help you walk through the new Impact software.
So thanks for joining us, everyone. Thanks, Steph, for presenting, and have a great day.
See ya.